What if I told you that 27% of our universe might be a lie? Or, even more intriguing, what if it's all an elaborate hoax? A cosmic sleight of hand with galaxies and stars as the magicians, deceiving us into believing in something that isn't there. But how could something so invisible have such a visible impact? And if it's not real, what's the alternative? Well, to answer these questions, we'll have to dive deep into the very fabric of our universe. So, are you ready to journey into the dark? Or should I say, the dark matter? When we talk about something as enigmatic as dark matter, the term hoax might seem a bit out of place, even scandalous. But it's a word that instantly captures the imagination, conjuring up images of smoke and mirrors, illusion, and deception. So, why is it that some people raise an eyebrow and even go so far as to label dark matter a quote-unquote hoax? Well, you see, in the scientific community, skepticism is not just tolerated, it's encouraged. The beauty of science lies in its self-correcting nature. But dark matter challenges us. It doesn't interact with light, it doesn't emit or absorb any form of electromagnetic radiation, and yet we say it makes up about 27% of the universe. For some, that's a tough pill to swallow. In our quest to understand the universe, we've sometimes stumbled. It used to be generally accepted that our planet was flat, and that the sun revolved around the Earth. These were once mainstream thoughts that turned out to be wrong. Could dark matter join this list? That's a question that keeps some skeptics up at night. In a way, labeling it as a quote-unquote hoax can be an extreme form of this skepticism. It suggests not just a questioning of the evidence, but also the implication of deceit or misinterpretation on a grand scale. The term hoax elevates the debate from one of mere scientific inquiry to one that questions the very integrity of the scientific process. But is it fair to use such a loaded term? To unravel this, we'll have to dive even deeper into the cosmic pool of dark matter, peering through the veils of data, theories, and yes, skepticism. Together, you felt an invisible force. You can't see it, but you know it's there because you can feel its effects. In a way, dark matter is similar. An invisible force making its presence known through its gravitational effects on visible matter. But unlike magnets, dark matter doesn't make itself known through touch or any of our other senses. Take, for example, the largest structures in the universe, galaxy clusters. These colossal groups of galaxies are bound together by something. According to our best calculations, it's not just the gravity from the stars, planets, and other forms of normal matter. There's something else, something we can't see. Now, you might be thinking, if we can't see it, how do we know it's there? Which is a good question. Let's talk about the Bullet Cluster. In 2006, astronomers observed this fascinating example of two galaxy clusters colliding. The hot gas, visible through X-ray, slows down during the collision, but the rest of the matter keeps moving. If gravity were solely due to the visible matter, we would expect the mass to align with the gas, but it doesn't. Using gravitational lensing, a technique where the bending of light is used to weigh massive objects, astronomers found that most of the mass was separate from the visible gas. This invisible mass is what we believe to be dark matter. You might wonder, if we've never actually seen dark matter, should we consider it just a hypothesis, or has it reached the status of a theory? In scientific terms, a hypothesis is a testable idea, while a theory is a framework for understanding various aspects of the natural world that is backed by substantial evidence. Dark matter initially emerged as a hypothesis to account for discrepancies in astronomical observations. However, due to the growing body of compelling evidence, like the Bullet Cluster and gravitational lensing, it has largely graduated from being a mere hypothesis. Today, it is a cornerstone of the standard cosmological model, even though a complete theory describing its nature has yet to be formulated. But even with such evidence, the term hoax still lingers in conversations about dark matter. How can something so proven, quote-unquote, still be the subject of such controversy. While dark matter holds a key position in our understanding of the universe, not everyone is convinced. So let's entertain the perspective of the skeptics for a moment, shall we? Skeptics argue that dark matter feels a bit like an invisible magical ingredient. It's convenient, filling in the gaps where our equations fall short. Why invent an invisible substance to explain gravitational anomalies? Could it not just be that our understanding of gravity is incomplete? They might ask. And that's a fair question. In fact, some alternative theories aim to do just that, modify our understanding of gravity. Take modified Newtonian dynamics, or MOND, for instance. MOND suggests that Newton's laws might not apply in the same way on galactic scales as they do on earthly or solar system scales. If MOND is correct, we might not need dark matter to explain why galaxies behave the way they do. Another sticking point for skeptics is the lack of direct evidence. Sure, we have compelling indirect evidence like gravitational lensing, but we've yet to find that smoking gun, a particle or clear, indisputable sign that dark matter exists. And let's not forget the history of science, which is peppered with ideas that were accepted and later overturned. Think about the concept that stress causes ulcers, for a recent example, which is widely believed until it was found that actually bacteria is often the culprit. Could dark matter be another such case? A scientific consensus waiting to be upended? Before we jump to any conclusions, let's consider the weight of the counterarguments. The skeptic's perspective, while intriguing, isn't without its own set of challenges. Labeling dark matter as a hoax is certainly provocative, but this term brings a set of complex issues to the table. First and foremost, the idea of a hoax suggests an intentional act of deception. Given the rigorous nature of scientific peer review and the collaborative quest for truth in the scientific community, the notion that dark matter is a grand, coordinated deceit is extremely unlikely, to say the least. Next, even if we dismantle the concept of dark matter, we are left with a gaping hole of our understanding of the universe. If it's a hoax, well, what replaces it? We're still left with the perplexing behaviors of galaxies and the mismatch between observed mass and gravitational effects. In short, throwing out dark matter doesn't solve the problems it was posited to explain. It simply takes us back to square one. Then there's Occam's razor, the principle that the simplest explanation is usually the correct one. If we claim that dark matter is a hoax, we need to develop a more complicated explanation for the observations it accounts for. Is it simpler to invent an elaborate conspiracy involving thousands of scientists? Or accept that there might be a form of matter we haven't directly detected, but that leaves traces through its gravitational effects? Finally, let's consider the range of independent observations supporting the existence of dark matter, from the cosmic microwave background to the intricate structures of galaxy clusters. If dark matter were merely a fabrication, all of these observations would need to be either misinterpretations or outright fabrications. In summary, while skepticism is a healthy part of scientific inquiry, the hurdles to labeling dark matter a hoax are both steep and numerous. So, if dark matter isn't a hoax, what do we actually know about it? Where is science on this mystery as of now? To start, we should note that dark matter isn't just a patch in our calculations. It's an active area of scientific research. Physicists and astronomers are utilizing a range of methods in their quest for direct evidence, from deep underground experiments that screen for dark matter particles to space telescopes capturing cosmic phenomena. One such experiment is the Large Hadron Collider, or LHC, in Geneva. Scientists there are smashing particles together at near-light speeds in the hopes of creating conditions similar to the early universe. They're actively looking for signs of dark matter particles in the debris of these collisions. Another approach involves using sophisticated telescopes to scan the skies for signs of dark matter annihilation. When dark matter particles collide and annihilate each other, they should produce a unique radiation signature. although we haven't found it yet, the search is far from over. Scientists are also delving into the theoretical realm. They're exploring candidates for what dark matter could be, like WIMPs, or weakly interacting massive particles, and axions. These particles are hypothetical, but they could fit the bill for what we've observed so far. One thing is clear. The field is rife with questions yet to be answered. However, these unanswered questions aren't indicative of a hoax. Rather, they exemplify the frontier of human knowledge. After all, the absence of evidence is not the evidence of absence. Let's pivot for a moment and discuss a fascinating disparity: the gap between public opinion and scientific consensus. Why is it that dark matter, a concept rooted in rigorous research and empirical data, gets lumped into the same category as conspiracy theories and pseudoscience in some public circles? Part of it is probably the allure of the unknown. Dark matter, with its elusive nature and enigmatic properties, easily captivates our imagination. It's a storyline filled with suspense. Scientists looking for an invisible substance that supposedly makes up about 27% of the universe. It almost sounds like science fiction, doesn't it? But here's where things get tricky. The chasm between specialized scientific knowledge and public understanding can be vast. This often leads to misconceptions. People might hear dark matter and think of it as a placeholder term for "we don't know." Similar to how ancient maps labeled uncharted territories as "here be dragons." Moreover, science is a continually evolving field. What's considered a fringe idea today might become mainstream tomorrow. But in the age of social media, where sound bites often drown out nuanced discussion, the line between skepticism and dismissal becomes increasingly blurred. It's essential to remember that science thrives on skepticism, but wilts under cynicism. While it's reasonable to ask questions about dark matter's existence, declaring it a hoax without substantive evidence is a leap that undermines the scientific method itself. In our quest to understand the universe, we're often faced with concepts that challenge our perceptions and stretch our imagination. Dark matter, with its ghostly presence, is undoubtedly one such enigma. But just as the universe itself is vast and ever-expanding, so too is our knowledge. Labeling it a hoax might be tempting because it sounds provocative, but the reality is much more complex and far more intriguing. Thank you for watching. If you enjoyed this dark matter deep dive, be sure to check out the video on screen next. It's another wonderful journey into the cosmos that I'm sure you're going to love. I'll see you next time.